Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 5, Lesson 4, which is on expected value pay to play. So yesterday we talked about expected value betting, where we were placing a bet on something, and if we won, we got certain payouts. And when you bet, you get your money back with your win. Now, expected value pay to play, here's the difference. So we're still looking at expected value, which is like a mean. We're still looking at a payoff times a win times the probability of winning, another payoff times the probability of winning. We still might have multiple payoffs there. The difference here is that your pay to play amount is gone. You don't care about the number of losses anymore because your pay to play amount is already gone automatically. You don't get that back. It's not like a bet. This would be similar to buying a lottery ticket. If you went to a gas station and bought a lottery ticket, the $1 or $2 or $5 that you spent on your lottery ticket is gone no matter what. So if you win, say, $100, you actually only won 95 because you spent $5 on your lottery ticket or whatever that might be. So that's the difference between paying to play and betting. So let's just go through some examples here. It's going to look very similar to yesterday with that one slight change. So find the expected value for pay to play. 2 dice are rolled, that's 36 total. You pay $2. If a 5 comes up, you win $6. So 5 is 1 and 4, 2 and 3, 3 and 2, and 4 and 1. So there's 4 wins. If a 12 comes up, then you win $10. That's just 1 win. And again, the difference today is we don't care about the losses. This is automatically out. So we don't need to go through the hassle of finding the losses. We're just going to set this up. I've got the expected value. I'm going to call this PTP, pay to play. So expected value pay to play is going to be a $6 win times the probability of 4 out of 36 wins plus a $10 win, comes from there, times the probability of winning of 1 out of 36. And then I'm straight up subtracting $2. I don't multiply it times the probability of losses because it's automatically gone. So if I go through the multiplication today like I did yesterday, so I'm just switching up my colors here. Let's say here I multiply here, that's 24 out of 36 plus 10 out of 36. And then you're straight up subtracting 2. So here's how I tackle this. I do these two things together first. That's the same thing as 34 out of 36 minus 2. And 2 is not a fraction, so here's where life gets a little tricky. If you don't remember adding and subtracting fractions, you have to have a common denominator, okay? Now, I'm not gonna go through the hassle of finding a common denominator for the 2. All I'm gonna do is, in my calculator, I'm gonna make sure that I put that in parentheses. So I open a parenthesis, type 34 divided by 36, close a parenthesis, then I type subtract 2 or minus 2. I get a expected value pay to play amount here of negative 1.06. And again, that's in dollars. We're finding the expected value in dollars. This is like your expected payout. So a negative expected value here, that tells you that probably not a good bet to take. Let's take a look at the next one. 2 dice are rolled, so that's 36 total. If a 4 comes up, pay amount is $1. You're doing expected value pay to play. If a 4 comes up, you win $12. So 4 is 1 and 3, 2 and 2, 3 and 1. So 3 wins. If a 7 comes up, you win $2. 7 has a lot. I think it's 6 of them, right? 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So 6 wins. And again, when you're doing pay to play, the money's automatically gone. Paying to play means your bet amount is gone. So you don't care about the probability of losses here because you're going to lose that money no matter what. So expected value pay to play, that is $12 payout for 3 out of 36 wins, plus a $2 payout for 6 out of 36 wins, minus your bet amount, which is $1, your pay amount, which is $1. And again, I don't factor the losses here. So if I put these together, I've got 36 out of 36 plus 12 out of 36 minus my dollar. Combine those, because those are your fractions with the common denominator here. Well, and in an essence, actually, this 36 out of 36 is the same thing as 1. So all that's going to end up happening here is this is going to cancel that. 1 minus 1 goes away, and you're left with just 12 out of 36. So kind of nice here. You have a positive amount. 12 out of 36 is a third. 0.33 repeating. Okay. You have a positive expected value amount here. So that's good. I mean, the average is a win, and that's probably because of this. This is a very low pay-to-play amount. So it's not very expensive to play this game, and that's a pretty high payout for 3 possible wins. So that's where you end up with a positive value there. All right, let's take a look at the next one. 2 dice are rolled, pay $2, so that's 36 total. If a 2 or a 12 comes up, that's only 1 and 1, that's 6 and 6, so 2 wins. If those come up, you win $8. If a 3 or 11 comes up, 3 is 1 and 2, 2 and 1. 11 is 5 and 6, and 6 and 5, so 4 wins. That you win $6. And if a 4 comes up, we did this in the last one, 1 and 3, 2 and 2, 3 and 1. 3 wins, you win $3. All right. Let's mark it out. And again, paying to play, so I don't care about the losses. So expected value, pay to play, looks like my win here, $8 times 2 out of 36 wins, plus $6 times 4 out of 36 wins. Did I say times? I meant plus. Plus $6 times 4 out of 36 wins. One more payout, plus $3 times 3 out of 36 wins. And then minus my bet amount, which is just a straight up $2. This gives me 16 out of 36 plus 24 out of 36 plus 9 out of 36, and then minus 2. I'm going to put these fractions together first, because again, common denominator here. So I'm going to add the tops. 16 plus 24 plus 9 is 49. So that's 49 out of 36 minus 2. And again, you can just type this into your calculator, but make sure you put parentheses around the fraction. So I'm going to open a parenthesis and then type 49 out of 36, and then close my parenthesis, and then subtract $2, and I'm at a negative 64 cents here. So this is negative 0.64 for my expected value. So negative payout, negative average means the house is winning. Let's now look at some with some cards. Standard deck of cards, 52 total. You pay $1. That's good. It's a cheap game to play. If you win $4 if a spade comes up, so that's 13 wins. You win $10 if a red ace comes up, that's 2 wins. And since you're paying to play, you don't care about the losses. So here's my expected value for pay to play. That was a P there, sorry. So $4 win times 13 out of 52 cards for probability of winning, plus $10 win for 2 out of 52 cards, minus your bet amount, which is $1. 4 times 13 is 52. So 52 out of 52 minus 20, or sorry, plus 20 out of 52 minus 1. Here's another one where, yes, you could go ahead and add these two things together and then subtract the 1 at the end, but hopefully some of you will recognize that 52 out of 52 is 1. So this 1 minus that 1 is going to go away, and you're left with just 20 out of 52. Little less than half there. Let's see what we get. 20 divided by 52 is 0.38. So that's an expected value of 0.38, so 38 cents if you look at it that way. positive expected value. It's not great, it's not super high, but it's a positive, so that means on average people are winning this game. And again, this was a low pay to play amount. You only had to pay $1 to play, so that is part of why you stay in the positive there. Let's look at example 5. Standard deck of cards, 52 options, 52 total. You pay $5. Ooh, that should tell you something. So $8 if a red face card comes up. Let's talk about red face cards. So face cards are Jack, Queen, and King. And red would be in hearts or diamonds. Okay, so you're going to have 3 in hearts and 3 in diamonds, so there's 6 wins there. Then $7 if a 2, 3, or 4 comes up. There's 4 2s, 4 3s, 4 4s. That's 12 wins there. So now my expected value for paying to play is going to be $8 times 6 out of 52 wins plus $7 times 12 out of 52 wins minus your $5 pay to play amount. That's an expensive game to play. This gives me 8 times 6 is 48. 48 out of 52 plus 7 times 12. I don't know that off the top of my head. 84, I think. 7 times 12. Let's check myself. Yeah, 84. 84 out of 52 minus $5. I'm going to put those two things together. 48 plus 84 is 132. So 132 out of 52 minus 5. And again, you can put all this in your calculator at one time, but put parentheses around your fraction. So I'm going to open a parenthesis, type 132 divided by 52, close my parenthesis, then type minus 5. You end up here with negative 2.46. So on average, the average win here is negative $2 and almost 50 cents. Definitely don't play this game. Not worth it. Definitely not worth it. Let's try a different kind of example. So we're still doing expected value pay to play. A box with 4 red marbles, 5 blue, and 11 green is established. So that's 11 plus 9, so 20 total. All right, so now you're going to pick one marble. You pay $1 to play. You win $2 if a red marble comes out. So red is 4 wins. You win $1.50 if a blue marble comes up, and that's 5 wins. So two possible payouts here. Oops, let's look at our expected value. So expected value pay to play. I've got a $2 win times 4 out of 20 for the probability of winning, plus a $1.50 win times 5 out of 20 for the probability of winning, and we're paying to play, so we just straight subtract the bet amount. Oops, minus 1 there. So then multiply your tops. I've got 8 out of 20 plus 7.5 out of 20 minus 1. Add those two up because those are your fractions. That's 15.5 out of 20 minus 1. Then type this into your calculator. You put your 15.5 out of 20 in parentheses. So 15.5 divided by 20, and then minus your 1, negative 0.225, or in other words, negative 0.23 is roughly your expected value. Negative expected value, but not a horrible negative expected value. We've seen worse. So maybe still worth playing, especially with such a low pay to play amount. You might win something. You never know. All right, last example that we're going to look at. So example 7, we've got 14. This is another box with marbles. So 14 red marbles, 25 blue marbles, 21 green marbles. So 25, 46, 48, 49, 50, 60 total. Hopefully I did that math right in my head. All right, so we pay $1 to play. You win $2 if a red marble comes out. That's 14 wins. You win $1.50 if a blue marble comes out. That's 25 wins. So what's happening here? I've got an expected value of paying to play of $2 times 14 out of 60 plus $1.50 times 25 out of 60 minus your bet amount or your pay to play amount, which is $1. Multiply and multiply. 2 times 14 is 28 out of 60. 1.5 times, that's 37.5, I think. 25 times 1.5, 37.5. 37.5 out of 60 minus your amount. Put your fractions together, add the tops there. 28 plus 37.5 is 65.5. So 65.5 out of 60, that's over 1, so you're going to get a positive number here. When you type this into your calculator, put your fraction in parentheses, open a parentheses, 65.5 divided by 60, close parenthesis, minus your 1, negative 0.09. Or sorry, not negative, positive. Positive 0.09. Now, it's not a huge positive, but it's still positive nonetheless. So that tells you that this might be a bet that's worth taking. So again, paying to play is where you just straight up lose your pay to play amount. You don't have to factor in the probability of losses because you always lose it. So you usually end up with lower values here. You end up with more negatives because you're not factoring in that probability there. So that's going to take us to the end of our notes for today. Thanks for tuning in. If you have any questions, let me know, and I will catch you next time.